Solving exponentials with logs. So a little review reminder, we have solved exponential equations in the past, and the way that we did that is we made a common base. So like if we had 5 to the n plus 10 equals 25, we could change 25 to be a 5 squared. And now that we have a common base, we know that the exponents have to match. So we could write the equation n plus 10 equals 2. And we get that n equals -8. So the question becomes, how if we can't create a common base? So if a common base is not possible, what we do is we take the log of both sides. So let's say we had 2 to the x power equals 61. So 61 is not a multiple of 2. So again, this is one of those we cannot change and have common bases. So it's very much like doing the inverse operation on both sides. The opposite of an exponent is a log. So I'm going to take the log of both sides. Now, if you remember the power rule for logs, exponents actually can be put into the front as coefficients. And this is exactly what you want to do because you're getting your exponent variable out of the exponent. So you're getting your variable out of the exponent. So this becomes x times the log of 2 equals the log of 61. So if I want to get x by itself, what I can do now is divide both sides by the log of 2. And if I put into my calculator the log of 61 divided by the log of 2, I get that x is about 5.93. So x is not a whole number. This is an interesting decimal, but we were able to solve it by taking the log of both sides. So again, that exponent becomes a coefficient is going to be what you're using in these problems. So let's try another one. In a problem like this, your exponential part is not by itself. So your first step is to get it by itself. We need to isolate the exponent part. So I'm going to add 5 to both sides, and I'm going to have 4 to the 3x equals, and that's an 8. So I can actually make this problem common bases. I'm just not going to right now. So if I wanted to, I could make these all powers of 2. I'm just not going to right now. I'm going to take the log of both sides. And again, my exponent is going to drop down in front. So I'm going to have 3x times the log of 4 equals the log of 8. I'm going to divide both sides, so I want to get x by itself. But right now, x is being multiplied by 3 and the log of 4. So I can divide both sides by 3 times the log of 4 to get my answer. Now, if you're not sure how to put that in your calculator, you could always do the log of 8 divided by the log of 4 first, hit your equal sign, and then divide that by 3. It's going to get you the same answer. So if I put into my calculator, and I'm going to show you, I can actually do parentheses if I wanted to. I'm going to do 8, and I'm going to click the log button. And I'm going to divide that by, and now if you can use parentheses, and you actually can on an Apple device too, I'm going to go 3 times 4 log, close parentheses, and I'm going to hit equals, and I get 0.5. Now let's see if it works the other way around. So I said x equals 0.5. If I had done the log of 8 divided by the log of 4, hit equals, and divided that by 3, I would still get 0.5. So either way, I get 0.5. If I had changed those to be common bases, I'd also get half, 1/2. Okay? On number 3, I first need to get my exponential part by itself. So I'm first going to subtract 7 from both sides. -2 times 5 to the x power equals -70. I'm going to divide both sides by -2 so that I have my 5 to the x power by itself. So that equals 35. And I'm actually going to move my 35 over so I have room for my log. I'm going to take the log of both sides, taking my exponential out of my exponent. So I have x times the log of 5 equals the log of 35. And to finish this, I divide both sides by the log of 5. So if I put into my calculator the log of 35 divided by the log of 5 and hit my equal sign, I get that x is about, I need to make that a squiggly equal sign because it's about, it is about 2.21. Okay, last problem. I'm going to do this problem in two different ways because this problem has an e. So when you look at this, you might be thinking natural log instead of just regular log. Well, our first step is still the same. We need to get the exponential portion of it by itself. So I'm going to subtract 3 from both sides. I'm going to get e to the x plus 2 equals, and 7 minus 3 is 4. So if I took the log of both sides, let's just say I was doing exactly what I was doing before. I took the log of both sides. My exponential will drop to the front as a coefficient. So I'm going to have x plus 2 times the log of e equals the log of 4. I'm going to divide both sides by the log of e, and I'm going to get x plus 2, and I'm going to put about because I am actually going to approximate this first before I deal with my plus 2. So in my calculator, I'm going to put the log of 4, and I'm going to divide that by the log of e, and I'm going to get about 1.37. Now, leaving that in my calculator, I'm going to subtract 2 from both sides, and I'm going to get about negative 0.61. Now, let's just say that when you looked at this problem, you were thinking e, so you're thinking this must be a natural log problem. You can actually use the natural log on this problem. So in this problem, let's start off with that e to the x plus 2 equals 4. If you took the natural log of both sides instead of just the log, you're going to get the same answer. So the x squared still drops to the coefficient. So we have x plus 2 times the natural log of e equals the natural log of 4. I'm going to divide both sides by the natural log of e. So I'm going to use a different button on this one. So I'm going to have x plus 2 equals, and I'm going to go the 4 natural log divided by e natural log, and I get 1.38. If you'll notice, or 1.3, I think I approximated the last one wrong. 1.38, and if I subtract 2 from both sides, I get about negative 0.61. I approximated this one incorrectly. That should have been a 0.38. So either way on this problem, you could use log or natural log. You get the exact same answer.